In this video, I'm going to be testing the impact that wheels have on the efficiency and the range of your electric vehicle. And the contenders for this video are the original wheels, some bigger alloy wheels, and then a set of ultra skinny, ultra light Spacesaver wheels. I'm going to run all of these, we're going to compare them, we're going to see which is the most efficient, we're going to see what the difference is. Is there much of a discrepancy at all, or is it all much of a muchness? We know what the theory is, but what's going to be the reality in the real world? Now, a bit of detail about the wheels that we're testing here. First of all, the original wheels. These are 16-inch alloy wheels that come with the vehicle. They are 6.5 inches wide. These are fitted with 205/60/16 tyres. They are Michelin on the front, and they are the original manufacturer fitted Bridgestones on the back. So a mix of tyres. These Spacesaver wheels, these are just 4 inches wide, 17-inch diameter, and this is running a 155/70/17 Continental Tyre. And last but not least, we've got some 17-inch wheels. They're MG wheels, they're from a HS. They are also 6.5 inches wide, but they are just on cheap budget Accelera tyres, no efficiency super duper tyres. These 16-inch and 17-inch wheels are the same offset, so it shouldn't affect the suspension geometry, and the Spacesaver ones obviously are going to be a bit funny. Anyway, let's get on with the testing. If you can hear me, before we set off on this little experiment of testing which wheel's the most efficient, we're checking all of the air pressures. So we're pumping up all the tyres now to the correct pressures. We're going to get them all set and make sure that we're giving it as fair a comparison as possible. All right, time for a quick weigh-in. So first wheel and tyre, we're going to call that 20 kilos. This is one of the 17-inch wheels that's about to go on the car with a brand new tyre fitted. Okay, here we go with our second contender. This is the original 16-inch alloy from the MG. We call that 18. Oh, 18.1 kilos. Done. Third up, 15.7 kilos, and this is a steel Spacesaver. Okay, now we're on the road. Let me explain a little bit about how I'm going to do this testing. So I've plotted a little route. It's a road I know very, very well. So I'm riding from here, from Southampton. Wow, that is an interesting golf cart on the side of the road. I don't know if the camera caught that in the background. Pause and zoom in. I'm driving from here in Southampton up to Stockbridge. I'm going to loop around at Stockbridge and head back to Southampton. It's a route I used to do for my work commute. I know that it's about 15 miles each way, and we go through the town of Romsey and then loads of little villages and hamlets along the way. Normally there's not really much traffic build up, but we might experience a little bit in and around Romsey. Let me tell you about the conditions today. It's been overcast all night, so I wanted to pick a day where the temperature would be very stable. I didn't want to pick a day where it'd be freezing cold in the morning for the first test and then warm up throughout the day, which would skew my results. So at the moment, the car is reading 14 degrees and the weather forecast says it's going to remain consistent. It's nice, thick clouds, and hopefully that holds true. I'll be driving just as I normally drive. I do have the car in eco mode. I've got the regen set to the middle position, which is level 2. If I didn't mention, the test car is an MG5, standard range, nothing special. The state of charge at the moment is at 70%, and it's showing that I've got a range of 143 miles. What I might do is I might actually just set my cruise control, even though I'm very familiar with this road and I'm confident that I can drive in the same way every time. I think to give us the best control on this test, we will try and just set, so I'll just set my cruise control for 50 in this section, and we'll see how we go. I won't bore you to death for the whole journeys backwards and forwards. Maybe you'll get a bit of time lapse, and maybe the future me editor version will put something a bit more interesting in. But I will catch up with you when I get to Stockbridge. I'll let you know a little sit rep, how we're doing miles per kilowatt hour, how many miles covered, and then when I get back as well, I'll do a little debrief on the first test on the original wheels, and then we'll swap over. And I think next we'll go for those skinny Spacesaver ones, see if there's a big difference. If not, then we will change onto the 17-inch wheels on the cheapo budget tyres, see what effect that has. Alright, this is your first update. I've made it to Stockbridge. We are showing on the trip meter 14 miles at my roundabout, that is my turning around point for heading back, and we have averaged 4.2 miles per kilowatt hour, which is perfectly what I've come to expect from this car. In these conditions, it's 14 degrees, solid temperature. We've used 5% of the battery, so it's 65% that we're down to now, and we're at 14 miles, 4.2 miles per kilowatt hour. We've turned around, we're heading back to Southampton for a quick wheel change. Will it be an F1 style pit stop, in and out in 3 seconds? I doubt it very much. Okay, I'm back where I started, and let me talk you through the numbers. Okay, here you go, a little shot. So the battery is now down to 59%. We've covered 27.9 miles and averaged 4.8 miles per kilowatt hour. Let's do a wheel change. What do you think then? That gives the car a bit of a look on the skinnies. All right. Well, I'm going to do the other side off camera and then we'll head off. We're on our way on the 4 Spacesavers, but I can almost hear you typing in the comments right now. 2 questions. Is this legal? And is this safe? Now, the legality situation, I tried to do a bit of digging, and I can't say comprehensively. I can say don't try this at home, just to be on the safe side. It appears that this would be legal to do this. Safety. Is this safe? Well, the reason that I've picked this particular trip is that these wheels, they basically say maximum speed 50 miles per hour, maximum range to drive on about 50 miles. So we're below the 50 miles range, and I've of course kept below 50 miles per hour on the first run to make sure I don't need to exceed 50. Most of the journey it's more 30, 40, 45. Even when you're in some of the 50s, it's difficult to drive at 50 down that road. Now the handling is very strange all of a sudden with these skinny light front wheels, but it feels stable enough. It's just the steering is very, very light. The wheels in question are from a Mercedes CLS. So a much bigger, heavier vehicle than this, even once you factor in the battery, the CLS, especially some of the CLSs with the big engines in, which these spare wheels are used for, big V8s or big V6 diesels or something. Some of those are pushing 2 tons almost. So they're comfortably within the weight limit of this car, and so I feel like I should be comfortable on them. In the past, I had a Mercedes S-Class which didn't have a full-size spare or Spacesaver spare in it, and I did use one of those CLS wheels on my previous S-Class and no issues at all. So I've got confidence in these wheels, and I had to do a little bit of digging to make sure I would get some that would give us a kind of fair test. So let's just talk about what are the factors when it comes to wheels and how they affect efficiency. The first one is the weight of the wheel, especially the reason why vehicles are quite sensitive to it, because it's rotational mass. So it's not just weight that you're putting in the vehicle, it's weight that the engine or motor is having to physically twist and turn and use that torque to overcome the forces. So the rotational mass. Now these wheels, as you saw at the beginning of the video, I weighed them up. These are significantly lighter than the other wheels. So straight away on that part of the equation, these should be much better. The second part is aerodynamics. Now these wheels have a relatively flat face on them, so they should help with aerodynamics. I'm not an aerodynamicist or aerodynamic engineer or anything like that, so take what I say with a pinch of salt. But from my basic understanding is wheels that sit further in the body line of the car, they have greater protection from the wind, and so they have less impact on the overall aerodynamic efficiency of the vehicle. So if you have very wide wheels that stick right out to the arches, they are going to be creating more turbulent air and more interaction with the air as it passes over the vehicle. So we should have an advantage both on the mass, the rotational mass, and on the aerodynamics. And the third one then is the rolling resistance, the actual friction between the road and the tyre itself. If you want a really amazing explanation of this, go to Engineering Explained. I think he's a nice Canadian guy, but American, Canadian, whatever, it's all the same to us Brits. Sorry, I apologize for my outburst. He explains it so well that when you go to a skinnier tyre, the amount of force pushing down on it is still the same because the weight of the vehicle hasn't changed. So your contact patch shape changes, and you just go from a wider, shorter contact patch. Keep your hands on the steering wheel, or you get everyone in the comments telling you. Then you change the shape of the contact patch to a contact patch that is skinnier, yes, because we've gone from 205mm wide tyres to 155mm wide tyres, but we're still putting the same force on the tyres, so that force spreads the load and then squishes the tyres a little bit more, and so the contact patch lengthens forward to back, if that makes sense. So whether we can reduce our rolling resistance by going to these skinnier tyres, that remains to be seen, and watch the Engineer and Explain video if you want to understand that in much greater depth and with much more comprehensive explanation. But these Continental tyres, are they efficient? I don't know. What kind of compound have they got? Wow, these Spacesaver wheels are so noisy. Always got the droning in my head now. I should have worn my noise cancelling headphones or something. Compared to those Michelins I had on the front and the Bridgestones on the back, these guys, these new Spacesaver thin Continental ones, incredibly noisy. Anyway, you're not here for that. Let me show you the stats. So we managed the same 0.8 hours, 28.2 miles, 32 miles per hour. Actually, the distance is slightly different because probably something to do with the rolling radius. You can see now the speed and the time are changing because I'm parked, but it was 0.8 and 32 miles per hour and 5 miles per kilowatt hour. So at least they are more efficient, and this wasn't all wasted. And the temperature, just as I was coming around the corner, has just tipped up now to 15 degrees. So, but it was 14 degrees, the same as the first run for most of the journey. Let's switch the other wheels on. Let's do the final part of the test. So now we're on the 17-inch wheels. First perceptions, initial impressions. I am glad that they are a lot quieter than those Spacesavers that we were just on. Otherwise, it all feels good, drives straight, and it is definitely a little bit firmer than the 16-inch wheels, but there's not really anything in it. The tyres I fitted on the 17-inch wheels are 205 55 16 not 16, 17 inch. Too many numbers again, I'm all jumbled up. So they are the same width as the original wheels, 205 millimeters. I know that the facelifted version of this, it comes on 215 50 17, which I don't know why they've done it. It's 10 millimeters wider, but it also means that the overall circumference, the rolling radius of the wheel and tyre package is slightly smaller when you compare a 215 50 17 to a 205 60 16 that these originally came on. So I went with a 205 55 17. Also, the wheels I've put on this car, they are 6.5 inches wide, whereas on the later facelift vehicles, I believe the wheels are now 7 inches wide. So there is a reason to go for a slightly wider tyre if you've got a slightly wider wheel. But anyway, I will stop rabbiting on, stop the waffling, and I'll give you a check-in when I get to Stockbridge, and let's see how it goes. So far, it's exactly the same as the other wheels, but I think we need a bigger test size to really pick apart the differences. Okay, 17-inch wheel, alloy wheel test. We are back in Stockbridge at our 14-mile marker, and I'm just about to turn around. Any guesses? What do you think are the findings? How do you think we're doing? No, it's not 4.2 miles per kilowatt hour. It's 4.1. So we've averaged 4.1 miles per kilowatt hour, and we've done pretty much everything else the same. Yeah. All right, the figures are in. We're back. Here we go. 4.6 miles per kilowatt hour. It's just dropped down to 31 miles per hour average speed, 0.8 hours, and covered 27.8 miles according to these wheels and this gearing and everything else. And we're now down to 34% battery after all of that backwards and forwards. Right, only one thing left to do, to the spreadsheets. Right, this video's gone on way too long probably from the footage, so no fancy graphs, no massive conclusion. Here is the data, okay? Let's just start off by examining the discrepancy in the distance recorded, because I drove the exact same route. I know it's the same distance, but this difference is because of the circumference being different on each of the wheels. You just can't get them to be identical sizes. Unfortunately, that's just the way it goes, because we go between 5 percentage points in tyre sizes, so it jumps up and down quite a lot. But you can see I've got them as close as possible. They're within 1% over here, and also the distance is almost within 1%. So actually the circumference on the Spacesavers in theory is smaller than the actual reality, and it's the other way round for the 17-inch wheels. I don't know what could cause that, because of course we checked all of the tyre pressures and made sure that we were bang on. Anyway, same amount of time and average speed, at least with the data that is shown on the screen. Not enough decimal places. This is my biggest conclusion from this little experiment. Miles per kilowatt hour, 4.8, 4.6, the worst on the 17-inch wheels, the best on the Spacesavers. And because we don't have any further decimal places, we only have the Spacesavers are basically 4% better than the 16-inch original wheels, and the 17-inch wheels are basically 4% worse than the 16-inch wheels. So overall, we've got a reasonable difference between them. And you can see here the weight difference. The original wheels are 18.1, then the Spacesavers at 15.7, and the 17-inch wheels at 20. So again, the difference is kind of similar. The Spacesavers are 13.3% lighter, and the 17-inch wheels 10.5% heavier. But I've done a little bit of correction here for the distance. Because the distance was out, that of course affects the difference on the miles per kilowatt hour, and I haven't put it in there because we just don't have enough decimal places. But if you were to take these correction factors for the distance, pop them on these numbers here, and you'd see that the gap actually shrinks a little bit. So the Spacesavers then only become 3.1% better because the car computer is thinking that we're going further than we really are. It's a little bit of a trick by putting smaller circumference wheels on, and because these 17-inch wheels are marginally bigger, actually our efficiency is slightly better than we think. But it's not a huge discrepancy, but we could, in theory, depending on the decimal places, we could be going from 4.17 down to 3.82 minus. But we, because we don't know exactly where we sit, we don't know when this rounds up or rounds down. We don't know if that's the car computers at 4.6 saying we're exactly bang on 4.6 or we're at 4.68. We just don't know when that trip's over. So anyway, I'd love to hear from you in the comments. We have found out that bigger, heavier wheels do cost you efficiency, but is it a price worth paying? Are you more interested in looks? Are you just interested in sacrificing any aesthetics just to get the absolute best efficiency? We're seeing a trend towards efficiency with wheel design and skinnier, more aerodynamic wheels, as well as these super crazy compounded tyres. The one thing that we haven't factored in here is we don't know enough about the compound of each of these tyres. We do know that the 16-inch wheels, they do have an incredibly efficient tyres, Michelin on the front and Bridgestone on the back, and they are their eco-efficiency tyres. The Spacesavers, we've got no idea, and the 17-inch wheels are just absolute cheapo ones. I think under the terrible grading rating system, they're C rated for efficiency, maybe B rated, but they're definitely not A rated tyres. Let me know what you think anyway. Good, bad, ugly. If you thought this test was good, then definitely give us a thumbs up. Consider subscribing for more rubbish like this, and look forward to seeing you on the next one. Bye bye.